Right now, above your head, beneath your feet, inside every wall of every plant on earth, a hidden network is keeping the modern world alive. You rarely see it. But the moment it stops, refineries go dark, water stops moving, power dies. We call it piping, and almost nobody understands the code that controls it. In the next few minutes, you will. Let's start at the beginning. A pipe is a straight, pressure-tight, cylindrical hollow built for one job: to move material from one point to another. Liquids, gases, sometimes even solids. If a plant is a living body, the pipes are its veins and arteries. As long as they flow clean, the plant lives. But not all pipes are born the same. The first thing that separates them is how they are made. A seamless pipe is formed in one piece, no joint, no weld. The choice for smaller sizes and higher pressure. A welded pipe is built from rolled steel, sealed along a seam, cheaper and the only practical option once the diameter grows large. 4 welding methods you'll meet again and again: SAW, ERW, EFW, and HFW. And in oil and gas, you'll see both seamless and welded carrying the same famous grade, API 5L. Now, what a pipe carries is only half the story. The other half is the metal itself. Engineers ask, how much tension before it breaks? That's its tensile strength. Where does it stop springing back and start bending for good? That's the yield point. They weigh toughness, hardness, how it survives heat and time. And then the real world. What does it cost? Can we get it? Can we weld it? That's why you'll find carbon steel, stainless, copper, nickel, aluminium, and plastics like PVC and HDPE. And when one metal isn't enough, 2 are bonded into a single clad pipe. Here's where it gets interesting. Pipe walls come in schedules. Schedule 40, Schedule 80. The higher the number, the thicker the wall, the more pressure it can hold. But there's a trap that catches almost every beginner. For small pipes, the number on the label is not the real outer diameter. A 1-inch pipe is actually wider than 1 inch across. Only when you reach 14 inches and above does the name finally match the measurement. Get this wrong and nothing fits. So how does an engineer keep thousands of these parts in order with the single most important document in piping, the pipe class? Picture building a massive Lego set with no instructions, a pile of correct pieces and no idea how they connect. A pipe class is those instructions. It defines exactly which components are allowed to work together. Pipe, fittings, valves, flanges, gaskets, all matched to the job. The fluid, the pressure, the temperature, the corrosion. High pressure steam? The class demands metals that can take the heat, with extra wall thickness built in for the years of wear ahead. Open a real pipe class and it's all there. The approved materials, the size range, how parts connect, threaded, welded, flanged, the full menu of components. Elbows, T's, reducers, and valves for every job. Gate, globe, check, ball. The corrosion allowance, the pressure and temperature limits, the branch tables, and the codes it must obey: ASME, API, ASTM. So remember this, a pipe is the conduit. A pipe class is the framework that makes every conduit safe together. If this finally made the network make sense, subscribe and head to AIEnginear.com for free engineering calculators to run your own numbers. Next time, we push these pipes to their limit and pressure test them until something gives. I'll see you there.